Hey ladies and gentlemen, this is Miss Humbert here. Today I'm going to be doing part 2 of your Unit 8 Notes 5. So we're going to talk about extraneous solutions. So I talked about on the previous part that that you can plug your answer back in and it should work, and that's how you know you did it right. Well, sometimes in the squaring process we end up getting two answers, two solutions, and one of them actually doesn't work. And that's where that plugging it back in and checking piece is going to become really important. So that solution is actually not a solution. It's called an extraneous solution. It's an extra solution. It doesn't count. Okay, so that's why we have to plug them back in and make sure they work. So let's go ahead and let's take a look at what that would look like. So here, I notice that my radical is already isolated, right? So I'm going to square it. Well, when I square it, what's going to happen? My x is going to end up getting squared. So here, I'm going to have x plus 2, and then on the other side, I'm going to have x squared. So I need to bring my x's over to the other side. What I'm going to do is I'm going to subtract over my x and my 2 because that makes it easier. So I have 0 is equal to x squared minus x minus 2. So now we have a quadratic. Now previously to solve quadratics we use zero product property and the quadratic formula. So that's what I'm going to do here. So I'm multiplying to 2 and adding to negative 1. That's going to be 2 and 1. So this is how I'm going to derive both of my solutions. So I have x squared minus 2x plus 1x minus 2. So then we're going to make two groups. So we're going to take an x out of the first group and we're left with x minus 2. Then we're going to take a 1 out of the second group because there is no greatest common factor in the second group. And then we're left with x minus 2. So now our leftovers are matching, so I can write those out. So I have x minus 2, and then I can write what's left after I take my leftovers out, which is x plus 1. So then I have x minus 2 and x plus 1. Now I just talked through that really quickly because I'm making the assumption that you guys are comfortable with the zero product property. If you're not, if that was too fast, you're confused, whatever, there's the note videos and the practice folders that you can look at, or on Schoology, or you can come talk to me during class. So what I'm going to do to use the zero product property is I'm going to set each of these equal to 0. So when you solve each of these for x, you end up getting 2 and negative 1. So now that I've gotten those figured out, I need to check. I need to plug each of them back in. So my original equation was the square root of x plus 2 is equal to 1. Is equal to x. So let's try plugging in 2. So the square root, now instead of writing x, I'm going to write 2. So the square root of 2 plus 1 is equal to 2. It's plus 2. Good job, Miss Humber. So the square root of 2 plus 2 is equal to 2. So the square root of 2 plus 2 is the square root of 4 is equal to 2. Square root of 4 is 2. Check, so that is one of my solutions. That one works. Let's check negative 1. So then I have the square root of negative 1 plus 2 is equal to 1. So then I end up getting, or negative 1. So now I notice that my radical is isolated on one side and it's set equal to a negative number. So since it's set equal to a negative number, negative 1 cannot be one of my solutions. So x is equal to 2. You do need to show the work of the checking. That's how you're going to get credit for this on assessments. You can't just assume it's going to work. You can't just plug it in your calculator and then tell me it's going to work. You need to prove to me that it did in fact work. So next, let's take a look at number 10. So for number 10, again, I'm going to square both sides because my radical is already isolated. So then I end up getting 4x minus 3 is equal to x squared. Now I like to bring the 4x and the 3 over to the other side because that keeps my a value positive. And that's just easier for me to work with when I keep my squared value positive. So I have x squared minus 4x plus 3. So now I can go ahead and I'm going to set up my x. So I'm multiplying to 3 and adding to negative 4. So I'm multiplying to a positive product and a negative sum. So both my factors are negative. So I'm going to use negative 3 and negative 1. And now I'm ready to factor. So I have x squared minus 3x minus 1x plus 3. Factor by grouping. So then between x squared and 3x, I'm going to take out an x. And then I'm left with x minus 3. Then I can take out of the first group a negative 1. And so we're dividing, and the reason why I took a negative is because that middle sign is negative. Nothing divides x and 3, so I'm taking out a negative 1. And then I'm left with x minus 3, which is good because that's what I needed for my leftovers to match. So I have x minus 3, and then I have x minus 1. Now that's set equal to 0. So I need to set both of those factors equal to 0. So x minus 3 is equal to 0 and x minus 1 is equal to 0. So I end up getting x is equal to 3 and x is equal to 1. Now before I go any further and call this problem good, I need to go back and check it. So my original was the square root of 4x minus 3. So I'm going to go ahead and I'm going to plug that in. The square root of 4x minus 3 is equal to x, so I'm going to plug in 3. So wherever I saw an x in that original problem, I plugged in one of my solutions. I'm going to do this one solution at a time. So then I end up getting the square root of 12 minus 3 is equal to 3. The square root of 9 is equal to 3. Well, the square root of 9 is 3. 3 is equal to 3. Well, there you go. X equals 3 works. Now we need to check x is equal to 1. So I'm going to do the square root of 4 times 1 minus 3 is equal to 1. Again, wherever I saw an x, I substituted a 1. So then I'm going to get the square root of 4 minus 3 is equal to 1. Square root 4 minus 3 is the square root of 1. So the square root of 1 is equal to 1. So then I get 1 is equal to 1. So that one checks out as well. So actually both of my answers end up being a solution, and there is no extraneous solution. Next, let's go ahead and let's take a look at number 11. So the perimeter of a rectangle is 20. The dimensions are 4 and x minus 1. Find the value of x. So the perimeter is all of the sides added together. So I have a rectangle. This side is 4, this side is x minus 1, which also means that this side is 4 and that this side is x minus 1. Because in a rectangle, the opposite sides are congruent. So to get the perimeter, we need to add all of our sides together. So that is what I'm starting to do. And our perimeter is equal to 20. So this is going to be equal to 20. So before we can solve this radical equation, we have to do some simplifying. So I know that 4 plus 4 is 8. That's easy for me. Remember when you take and you add radicals, they have to have the same radical. Well, these two radicals are the same, so I can take the square root of x plus 1 and add the square root of x plus 1, and that gives me 2 times the square root of x minus 1, not x plus 1. And that's going to be equal to 20. So then what I want to do first is I want to bring that 8 over to the other side. So I'm going to go ahead and subtract 8 from both sides. So then I get 2 times the square root of x minus 1 is equal to 20 minus 8, which is 12. Then I'm going to take, and now I want to get rid of that 2. So I'm going to go ahead and I'm going to divide both sides by 2. So I get the square root of x minus 1 is equal to 6. So now that that square root is isolated, I can go ahead and I can square both sides. So then I end up getting x minus 1 is equal to 36. So now I can go ahead and I can add, hey Google Chrome, 1 to both sides, because now I'm just solving it like a normal equation. So I get x is equal to 36 plus 1, which is 37. And I checked, the original problem didn't give me a label, so I'm not going to have a label on number 11. Last but not least, let's take a look at number 12. So for number 12, the formula for the velocity of a moving object is v is equal to the square root of 2e divided by m, where e is the kinetic energy in joules, m is the mass in kilograms, and v is the velocity in meters per second. So here it's giving us all of the labels we need for each of the problems. What is the kinetic energy of an object that is moving 6 meters per second? So the kinetic energy is going to be the e. So this... Oh, what is the kinetic energy? So sorry, Miss Humbert. So we're looking for E. When we're looking for the kinetic energy, we're looking for E. It's moving at 6 meters per second. That is our V. And the mass is 9. That is our M. So let's go ahead and let's plug that in. So I'm going to have, the velocity is 6. So 6 is equal to the square root of 2 times E divided by 9. Now, we've been learning throughout this whole radicals unit that you cannot have a fraction underneath the radical. So what I'm going to do is I'm going to square both sides. And I'm just going to get rid of that radical altogether, because before we were dealing with expressions, now that we have an equal sign, we can square both sides. So I end up getting 36 is equal to 2e divided by 9. Now, that 2e is being divided by 9. So what I need to do to get it over to the other side is I need to multiply both sides by 9, because that's the opposite of dividing, right? So then I have 9 times 36 is 324, and that's going to be equal to 2e. So now I just need to solve that for E. So I'm going to divide both sides by 2, and I end up getting that E is equal to 162. Now I don't remember what my label is. So when I'm talking about kinetic energy, it says that kinetic energy is in joules. So my label for that 162 is going to be joules. So that's your final answer. And that concludes the second part of your note video. Make sure you take the part 2 Schoology quiz. Thank you for listening.